The first thing we worked on today was the do now, which you will see in your ClassKick document. So go ahead and pause this video and give these 4 questions a try. I'm going to do 2 of the questions. You should have already tried them on your own. What I really want to focus on is the notation, or how we want to be writing our answers to one-step equations, because it's going to affect us later on when we start to see more complex problems. If I have 7x equals 4.55, I know that I need to get x by itself. So I'm going to go ahead and I'm going to divide x by 7. And if I divide both sides on the left here by 7, I end up with x all by itself. And x is simply the quotient of 4.55 divided by 7, which is something that you would probably need a calculator for. But remember that when we have a fraction bar like that, 4.55 over 7, it does mean division, even when we haven't written with the actual division symbol. So you'll just go ahead and divide, and once you have your answer for x, you can always double check to make sure your answer is correct just by plugging x back into the original equation. 7 times 0.625 does equal 4.55, so we know that we're correct with this answer. Now for question 2, we have y divided by 0.7 equals 1080. And in this question, we want to get y by itself. So we'll multiply both sides by 0.7. It cancels out on this side. And we end up with y equals 1080 times 0.7, which is equal to 756. And again, you could always check your answer just by making sure that 756 divided by 0.7 is actually equal to 1080, which it is. And that's how you get your final answer for y. So go ahead and if you haven't already, please pause this video to answer questions 3 and 4. I want to see work from all 4 on the do now. All right, so in today's class, we did a few things. The first is I collected a page from yesterday, but that page from yesterday is actually something you're going to work on today. The page that I'm grading and collecting is this page right here, 2 and 3. So it's slide 3 for you guys. You'll see it when you get there. And we're finishing the rigid transformations unit today. We took that test on it on Monday, and we're finishing up with congruence today. Tomorrow we'll start a new unit. So for today in class, we completed lesson 13 and completed lesson 13 practice. But if you were absent yesterday, you only worked on lesson 11. So in this video, you are going to complete lesson 12, or at least the most important parts of it, and lesson 13. And you won't actually have to do the lesson 13 practice because you're out. So you can kind of cross that off on your list. You do need to complete the Khan Academy assignment. And if you failed your test, you need to attend office hours. But I don't think that applies to anyone who's currently on quarantine. All right, so let's talk about lesson 12 first. All of the translated images are congruent. Sometimes we need to take one figure to another with a translation. Shade the triangles that are images of triangle ABC under translation. So pause this video and answer 12.1. So there are 3 triangles that are images under translation of ABC, and I just shaded them in. We can tell that these are translations because remember that a translation is just a slide, and so the direction of the triangle can change, but it doesn't spin. Whereas to get from ABC to a triangle like this one, we would have to spin around. And so we know that the blue arrow is not a translation. Now, yesterday we learned about this new word called congruence. And congruent just means that it can be the results of a rigid transformation. And we have some examples of congruent pairs here. For each of the shapes, decide whether or not they are congruent and explain your reasoning. That word congruent just means that they could be the results of a rigid transformation. So go ahead and pause this video and answer the next 3 questions. It's going to be on slide 2 and 3 for you. Answer questions 1, 2, and 3, and unpause when you're ready. Okay, so you should have tried 1, 2, and 3. Let's just talk about 2 examples. We know that 2 is not congruent, and the reason why 2 is not congruent is because the angles changed. You also could have said that the side lengths changed, or you could have just simply said that they're not the same shape. Those all would have been valid answers for question 2. Now, question 3, we can see is congruent. We have the same base. The base is 2. And I can see that the first leg of the triangle is 2 over 4 down, 2 over 4 down. The second leg of the triangle forms a 4 by 4. If you were in class, you could have measured with tracing paper. We could perform a rotation in order to create this triangle, or we could perform a sequence of rigid transformations. Either way, you would want to tell me, yes, they're congruent, and then explain to me why. So what rigid transformation could we perform, or how else could you prove it? Make sure that you have a because statement in your answer. Okay, so those are kind of the most important points from lesson 12. And today in class, we worked on lesson 13, congruence. In 13, congruence, we continued to practice finding shapes that are congruent, but we refocused on less familiar shapes. So including talking about ovals, talking about irregular polygons, or shapes that are less familiar to us. And 13.1 is a good example. It tells us that these trapezoids are congruent, and it wants you to draw and label the points on ABCD prime that corresponds to E and F, and then label the points on ABCD that corresponds to G and C, and then it wants you to draw 3 more points. So go ahead and pause the video and try 13.1. Okay, so you should have tried 13.1. Let's just try a couple examples. I'll show you where point E is. If we can see that E is here on trapezoid ABCD, on trapezoid A prime, B prime, C prime, D prime, E is just 1 unit over from A. And we can tell that's true because this is a translation. The corresponding points A, B, C, D, C, D follow the same order. So make sure that you've also found F. Don't forget about F. And then when it comes to G prime and H prime, we can see G prime right here. And so we know it's 2 units to the right from D prime, which means it'll be 2 units to the right from D. Make sure you don't forget about H prime. We did G prime, but don't forget about H. And then it says draw and label 3 more points of pairs of corresponding points. So I could, for example, put a point, let's call it Q, between B and C. And then between B prime and C prime, I could put Q prime. Go ahead and do 3 more pairs of corresponding points. Pause if you need to, and come back from 13.2. All right, so in 13.2, it asks if any of the ovals are congruent. And with ovals, it's a little tricky, especially since you're not in class and you don't have tracing paper. But what I want to point out is that we can compare other measures of the ovals besides something like a side length. So do some investigating about these comparisons, about the width and the width and the height of the ovals, I should say, and tell me, are any of these ovals congruent, and explain to me how you know. Okay, so you should have answered 13.2. If you're still watching, you can always pause. I'm going to have you complete 13.3 and 13.4 on your own. I will go into your ClassKick and give you feedback, then send you an email about 13.3 and 13.4. When you're finished with 13.3 and 13.4, don't forget that you have a Khan Academy assignment that's due, and there's also an exit ticket in the main folder. On the last page of your ClassKick document, you'll see some helpful notes just summarizing congruency. That could be a good resource to wrap up the unit.